Here we have our moderator, Mr. Samuel Livingstone. He would be familiar to a few and new to the others. So Mr. Samuel Livingstone has completed his bachelor's in optometry from Sri Ramachandra Institute of Higher Education and Research, and followed by doing a fellowship in vision therapy from Shankar Netralaya, and he's also completed his FBDO from Shankar Netralaya. He's done his master's from Manipal University, and he is also a fellow of IACL. So I warmly welcome Mr. Samuel Livingstone as the moderator for today's session. Welcome, Samuel.
Thank you, Purnima, and it's good to see you all. Welcome, Monica ma'am. Such a privilege to see you. So good evening, ladies and gentlemen. A warm welcome on behalf of Optometry Association of Tamil Nanbarkal. I hope everybody is staying safe indoors and with a positive attitude. I know at this period of time, there are a lot of online platforms that are going around, but there is no stopping of education. So it's indeed a great joy and greet you all for the session on spherical equivalent of contact lens, soft contact lens, or soft Toric. What's the best recommendation? Before I introduce the speaker today, I would like to say something to the viewers. If you have any questions, you can kindly post it on the YouTube live chat box so that at the end of the session we can address it. Today I take immense privilege to have with us one of the most renowned personalities in our optometry fraternity, none other than Professor Monica Chaudhary ma'am. Welcome ma'am, and thanks for accepting our invite from OATN. Ma'am has done her MSc in optometry and she is a PhD scholar. She is a fellow of IACL and BCLA. She is currently the director in School of Health Sciences at Ansar University. Ma'am has nearly 33 years of clinical, industrial, and academic experience. She is a retired educator and optometrist of All India Institute of Medical Sciences and ex-senior consultant of Regimen. She has been previously associated with Amity University as the head department of optometry and vision sciences. Ma'am is also associated with a lot of international companies like Johnson & Johnson, Boston Law, Manicon UK, and many others. She is the chairman of Optometry Council of India and a governing force of National Association. She is also a member of task force by Ministry of Health and Family Welfare. We also know that ma'am has authored a lot of books on low vision, contact lens, and refraction, and she has published several papers. She has been awarded Stress-Free Award by the Delhi Citizen Forum for her contribution in academic and medical service. She has awarded Australian Leadership Fellowship Award in 2011, Global Educator of the Year in 2015 by the IACL UK, and she is a lifetime fellow of the IACL. Ma'am, it's indeed a great pleasure to have you for the session. I welcome you, and over to you, ma'am.
Thank you so much. A very good evening to everybody. I am humbled by all these words that you spoke. In fact, it was such a great honor, and despite too many webinars going in and back-to-back schedules happening, there was a thought, but the love with which you all had sent in that invitation, there was no way to say that yes. And the topic itself, bringing in this topic from people who are, I feel, experts in this subject sitting next to me, and there are some who would be looking into the fresh kind of information. So I tried to amalgamate everybody's needs and just bring in back, because I realized even when 34 years back when I was a student, we never had a topic like toric lenses. We learned more of it ourselves as we started doing the clinical practice. Being an educator, yes, I get a chance to read back my theory. But there are many more in the market who are sitting there who would not have gone through those theoretical components. So I think that may bring value to some of the senior people also who are already practicing, but would like to go back into the theoretical part of it also. So besides this, the topic as it itself says, we will start with the topic to bring in we will a learning outcome where we'll understand the soft toric contact lenses and we'll understand various techniques. But more than that, as I end up my presentation, I would be bringing in more of the clinical pearls in this. I'd love to have some questions and discussions on it so that we all can share our experiences. And to all the audience who's sitting here, especially the young ones, there is a short multiple choice question test at the end of the presentation. I request you all to be alert and please have your doubts in the chat box been put in so that Sammy can coordinate that if there is any clarification needed. So that MCQ test will also help you self-assess in understanding that yes, you are up to that level. So let's make it. Soft contact lens is a routine which we see in our fittings. So what is a toric lens? We all know toric lens is a lens which has two components. There's two different meridians, and these two meridians are 90 degrees apart, and that is regular astigmatism. When this is not 90 degrees apart, it goes into irregular astigmatism, and we have different kinds of lenses when we talk about it. So toric lenses for beginners, when we started years back, when they came into the market, was a specialty contact lens. Spherical lens, wherever it is in the eye, it goes and rests. You have to have a spectacle power conversion and put it on the eye. That is one you will marking yeah. Okay, let me just bring in.
This is better now.
Yeah, is it better? Just let me just do a little setting here. I think I've just put that batteries and all on. Is my voice better now? Is that better?
Yes, ma'am, it's better.
Okay. So now what is important in case of a soft lens, it has to be stable on the eye. That is more important. So if the optics of the eye needs 170 degree axis, we should be actually knowing that 170 should fit on the eye. So the lens has to be stable on the eye, which is more important for us to work on. And that's how we have to think about it. So what are the different conditions where it fits in? The different conditions where it fits in is, there are different factors in the eye. So you put a spherical lens, which is like a round ball, and you want to put in this lens inside the eye. The lid will push it and rotate it in one direction. The lower lid always has a horizontal movement. The upper lid has a down and out movement. There are tear film forces, the thickness of the lens, and various other things which are going to make the difference. So this rotational stability is required by various stabilization methods. So you have to stop this rotation on the eye. Various techniques, quickly run through these theory parts. 4 which we are knowing as theoretical: the Prism ballast, Truncation, Parrot Ballast, and double slab of techniques. We'll go each one separately. Now, there are some techniques which are more popular. Now, what happens is, the principle of stabilizing the lens, is based on watermelon seed principle. The lens, if you hold a watermelon seed in your hand, it will always skip off by the apex. The same principle, when you put in a toric lens in the eye with one edge thick and one edge thin, it's just like the lid's holding it and it will always stabilize at one position. So that is watermelon seed principle, which is mostly used in toric designs. And the best example to see that is the Prism Ballast design. The Prism Ballast design has a prism at the base, which is usually 1 to 1.5 diopter. When we put it in the eye, the thin zone will be held up by the lid, typically, as we said, like a watermelon, and the base will have a stable bottom. So the lens will rotate and fix at a particular axis only. The second method is truncation. Truncation means you're going to cut off, truncate the edge so that the lower lid is going to support that edge. This is a technique which is not usually used by manufacturers, more of a theoretical one. However, years back I had seen a truncation toric lens. The simple problem is this lens is little hard for the eye and is more, awareness is more. So the technique is not popular. We also have a combination of prism and this, which is called the Parrot Ballast technique. So here you see a prism form, which is like a minus carrier design. So all of us who look at spectacles, we know the lenticular design. So what they have done in Parrot Ballast, they've made an edge here, which is thicker so that it holds at the bottom and the lens can be perfectly stable. The upper lid will hold the thinner edge. There is another technique which is called reverse prism technique. Reverse prisms, so there are prisms which are base down and there is an inferior chamfer to integrate in the design. So you're rather creating two zones of thinness. There is one upper and one lower. So you shave off to make it thin and you have a base down prism in the center. Hence, the lens will not rotate and will stabilize on the eye. There are many more modern designs, and I just put in this picture. When you go into the catalogs of the manufacturers, you will find they have given innovations combining one technique with the other and have various other stabilization techniques in combination. Very importantly, I wanted to mention the ASD design, which is specially used by Johnson & Johnson EquiView lenses. It's a beautiful design according to us. So it has got 4 thick notches, which are the dark blue colors. And you see the light blue colors as the thin zones. So there are thick and thin zones in it. When the lens is put in the eye blinks, and within seconds you will find the lens, the thick zones are now in the open portion of the eye, and the thin fits under the upper and lower lid. This is a beautiful design as far as stability is concerned compared to a prism ballast design. Because the prism ballast design has a prism at the base, and with the movement of the head, the lens can have some kind of rotation. So these designs, okay. Now the other thing that we look into the toric lens are laser marks. Now for all friends, the laser mark does not mean axis. So if I say the laser mark is here, this does not mean that it is 90-degree axis. Whatever is the axis inside the lens, it can be 30, 40, 50 degree, 60 degree, whatever. The laser mark will always remain at these positions. So it is 6 and 12 o'clock laser mark position. This one is 3 o'clock, 6 o'clock, 9 o'clock position. This is 6 o'clock, 5 o'clock, and 7 o'clock position. So this is different. These are laser marks, which are actually just orientation marks, which help you understand when the lens is on the eye, a 6 o'clock should align with 6 o'clock and 12 o'clock should align with 12 o'clock. if the lens is moving, the 6 o'clock is moved to the different position. So these are laser marks, which are just orientation marks, and these are actually used for the assessment of fitting. So different manufacturers have different kind of rotation marks. Most of them use the 6 o'clock position mark, but we have Bausch & Lomb, which has 3 marks. So one has to imagine the lens in the form of a clock, and you have to imagine the eye in that clock. And if the position of these marks coincide with the cornea positions, that means the lens is not rotating on the eye. And as we go ahead, we understand if there is a rotation, we have to do some compensation in our prescription. So before I move on to, in fact, quite a few slides that I have next covered is talking about the power calculations, because this is the most important part in a toric contact lens. Most of the fittings are going empirical method. You have a patient who comes to you. You don't have to use trial lenses. You have to just get the patient's refraction, baseline findings, keratometry, and order. Now, ordering would depend upon a very, very good spectacle refraction. And that has to be done with the cross cylinder. Patient can be 6x6 with -1 with 0.75 cylinder. He can be 6x6 with 0.75 minus 1.25 cylinder. Now your 0.25 cylindrical and that 10-degree axis will also mean a lot when you prescribe a soft toric contact lens. Just a little bit of basic. You have a spectacle power of -3. We all know we order a contact lens of -3. If we have a spectacle power of -6, we go for a vertex distance correction chart and we order 5.5. Let's see what happens in toric contact lens powers. All of you in your chat box, and Senthil, please help me out. So there is a spectacle power which is -3 with 0.75 cylindrical, axis 180 degree. The contact lens, since you have a spherical component less than 4 diopters, we go with the same power and the cylindrical is copied. If the power of the spherical is above 4 diopter, like in this case it is -6 with 0.75, we would go for a 5.5 with 0.75 cylindrical. Now there is something else which we need to learn in this. So the thing that we need to learn here is, we always start talking about a toric contact lens, whatever may be the power, whether it is -3 with 0.75 or -6 with 0.75, anything where you have a 0.75 cylinder or more, we only think of a toric contact lens. And that is very important. And that will be where I will make you understand why. Because even in my book, when I had written, our generation, we had thick soft lenses. We used to use those formulas of 4:1, saying if your spherical component, like in this case, -6 case, if you are 4 diopters, 4:1 ratio, you can go for a spherical equivalent. No, but that is not what is going to happen now. It is typically any spherical power with 0.75 cylinder or more, prescribe it. I may exclude out a case of -20 with 0.75 cylinder. For your judgment, just think, there is a patient in front of you who has a -6 with 0.75 cylinder. The spherical equivalent could be a 6.37, however, let us say 6.25 or 6.5. Now, if I prescribe a spherical equivalent, would I get the same vision when I have the cylindrical or the spherical? Then why in contact lenses do we think of the same thing? The power calculation has to be done in both the meridians. So I just told you one basic fact, that if it is more than -4, you have to go for vertex correction. So -5 vertex correction from the table is 4.75. But in case of toric lenses, we do correction in both the meridians. The other meridian is -7, as you can see. -7 becomes -6.5. So the whole mathematics changes. The contact lens is now 4.75 because of this. The other meridian is 1.75 at 180 degree because I have to do vertex correction for both of them. For a quick reference, I know it may not be clear for all of you when you are looking into your small phones or iPhones. This is a quick reference chart. You can even download these charts and tables from the internet. You can request the manufacturer to give you these. So have these charts and you can just have a quick reference minus, like I said, -6 with 0.75 cylinder. So this has cylindrical powers and this has the column of sphere. So pick up the sphere, pick up the cylinder, and you can read the contact lens power from here. You also have apps, you have online calculators where you feed in the spherical lens power and the spectacle cylindrical, and you can actually have the calculator. But for any student, we prefer that you do those cross and mathematics to learn it. So the steps in calculation are: do a refraction in cylinder in minus cylinder form, do vertex distance correction, compensation of both sphere and the cylindrical separately, and next, very important, check with manufacturer's availability. Now, I may need a -1 cylindrical, but the contact lens manufacturing industry gives us contact lenses in 0.75, 1.25, 1.75, 2.25. It's a 0.5 step after 0.75. So suppose I need a 1.5 cylindrical, I will have to go for 1.25 rather than 1.5. So these are the steps, key messages again: good refraction and test the tolerances for excess rotation, which we will talk next. And we have to do the post-fitting evaluation, which is done with the slit lamp, optic section, or other methods that I'm just going to mention. So for all fitting, diagnostic was our generation time. You put in a lens, you see the rotation, you calculate the rotation, and then you order. No, with modern disposable lenses, you don't need to go in for a diagnostic trial set. You have to just do a good refraction, baseline findings, and send it to the manufacturer or straight away empirically get the lens box. Now this lens box which comes to you becomes your trial lens. Personal experience, 90% of the time, it will have no rotation on the eye. But yes, 10% of the time, we do see rotation. We do see the lens base curve not fitting well. We then request for a replacement by applying the rotation, axis rotation calculation rule. So the beauty about these lenses are, secondly, you cannot stock up your clinics with all combinations. Look at the spherocylindrical combinations. They make thousands of combinations. You may even have a plus sphere with minus cylinder, so that can never be stocked in your clinic. It has to be through the distributor that you do the empirical calculation and then do the ordering. You may rather take the money as an advance at the same time and let the patient come. When the patient comes, your lens becomes your trial lens. As I said, 90% of the time it is going to be fitting well. If not, you will have to do the toric calculation. Okay. So when we want to do the rotation, now again remember we made this green color. It's not green actually when you see it on the eye. These are all laser marks like an etching mark on the lens. And of course, remember these etch marks do not cause any complication in the eye. So what you have to do is make the patient sit on the slit lamp, make an optic section and see if the 6 o'clock position is 6 o'clock or not. In this case, as you see, the 6 o'clock position has moved a little bit here. So there is a rotation. And that's where, when you imagine the wall clock, and in the wall clock, you have to imagine we all are used to it. So if it's midway between the 2 hours, it is 30-degree rotation. So if the rotation is midway, you know it is 15-degree rotation. So this is a little bit of judgment for a fresher to do, but it is very, very easy to see and assess this. So the orientation mark has to be at the position specified by the manufacturer. If he says my orientation marks should be 3 and 9 o'clock, you assess it horizontally. So this is, again, any calculation in the rotation, you have to reorder and make sure when the lens which will come back with the calculations added in it, the lens finally will still show the same rotation. But I'll explain you why. So there is a rule which is Lars rule, and we all are well aware of it. Easy for us to remember: left, add, right, subtract. It means if there is any rotation to the left hand side, your left hand side, you have to add that many degrees to the spectacle cylindrical axis. If it is rotating to the right hand side, as many degrees it has rotated, you have to subtract from the spectacle cylindrical axis. So if the lens does not, if there is no rotation, you are perfectly, whatever the spectacle power, the same contact lens, the patient will be wow 6x6. If the base curve is not fitting well, it will show some fluctuations. You then need to change the design. You then need to order to a different manufacturer, because most of the manufacturers will give you one base curve only in one type of lenses. Let's again see a case here which we would like to fit in with the contact lens. So we have S1, which has -3 and 5.25. That means -3 with -2.25 cylindrical at 180 degree. You have 3 does not need a vertex correction, but a 5 needs a vertex correction. So a 5.25 becomes a 5. So instead of having a spectacle power as -3 with -2.25, you need a contact lens of -3 with -2 at 180. But do we get a -2 cylindrical? No. So I have to order 1.75 cylindrical. When this lens comes to me, I put the lens on the eye, and now I would see the rotation. A simple example, if there is a rotation to the right hand side, my right hand side, as you see in this diagram, by 10 degree, Lars, left add, right subtract. I subtract 10 because it rotated by 10 degree from the spectacle axis. The spectacle axis is 170. So I now have to send back this lens to the manufacturer and order a new lens of -3 with -1.7 or 2.25 at 160 degree. I'm sorry, it's not 2, it's 2.25. So the manufacturer will take back the box with one open lens and give you back the other one with 160 degree. Now you may ask that the spectacle is 170, but we are fitting the lens at 160 degree. Why? Because this 160 degree lens, when it rotates, it actually goes back to 170 position. So the eye will have 170 position by the virtue of this rotation. So the patient will have perfect vision. However, the box axis, actually some patients question us, my number is this, why have you given me this lens power? We may have to somewhere in a layman form talk about it. I usually say, no, the contact lens powers are different. And as long as he can see 6/5, it does not matter to him then, and he's happy. So another quick example. If 3 with 2.25, 170, and we find rotation to the left by 15 degrees, we would add 15 to 170, we get 5 degree. So we will order 5 degree. Now there are manufacturers who do not give you 5 degree, they give you 10 degree steps. And I want to give you a question, which one do I decide? Whether I decide to give 10 degree in this case, or I decide to give 0 degree or 180 degree in this case. It depends on the right and left eye. Whether I go this side or that side, and I'll explain it to you how to take that example. Before that, I have something more to add. These are clinical pearls. The astigmatism prevalence is 47% of the patients have 0.75 of per diopter of astigmatism or more in at least one eye. And what is the kind of toric contact lens prescription? Average of the world is even 25%. We looked into the Indian distributors and market. They say we only sell 15% of our prescriptions are toric. We have 85% of orders which come into spherical soft contact lenses. But if we look into the data to say 47% of the patients need that cylindrical, we are barely giving it to 15%. And that's next few slides which I'll tell you. So India would need almost 50% of our patients toric lenses, which is not happening. And if it doesn't happen, there was a study which we did. And in this study, we involved our students. This was our master's student who helped me, Surinder and Indra. So we enrolled young people, young ATIs who had small cylindrical errors, 0.75, 1 diopter or 1.25 diopter. Their spherical number was anything between 0 to -6. What did we do in this case? Usually what happens, what we see, if a patient comes into an optical or an optometry clinic or an ophthalmology center, small cylindricals are just attempted to be taken as a spherical equivalent, and the patient is given a spherical equivalent. We understand the psychology. Practitioner wants to save the money for the patient. Second, if he doesn't sell a spherical lens, he will have to do empirical calculation, order, and then do a chair time in it. So it is a tendency of a practitioner to do a spherical equivalent, and then what he does, to satisfy himself, he makes that spherical equivalent worn on the eye, makes the patient read the chart. The patient can read 6 by 6. He feels, okay, you can see almost the same, or you missed 1 or 2 alphabets, no worries, but this lens is equally good for you. So considering those thoughts, we first gave the patient, all these patients with small cylindrical errors, the spherical equivalent lens. We assessed what we assessed objectively and subjectively also the vision. Subjectively, most of the subjects, and they were neophytes. Neophytes means they have never worn contact lenses before. They're spectacle users. The first go, all of them said, yeah, I can see clear. I'm okay. I'm satisfied. So we asked their gradings. After the spherical lens, we called them again and shifted them to their actual toric prescription. That is when the patient noticed the difference. And that is where our graphs and results were. So patients were misleading us. If I just gave him a spherical lens, since he could see the quantity well, and myopes usually whatever you give, they can. I can see the last line. Maybe I didn't read the last alphabet, but I'm okay. Are you seeing okay? Yes, I'm okay. So most of the patients had said, okay, I'm seeing good, satisfied, and there were some who said bad. But when we shifted them to the toric, everybody it was really then understanding, oh, that lens was pretty bad. This is much better. So the recommendation of ours, and then trying to judge our patient that are you seeing okay? that words will mislead us. So do not do that. This study clearly defines, do not experiment and feel that I have given a spherical equivalent. Many times when our patients come for a follow-up, which is from other places also, our students are in a tendency, ma'am, patient is fine, he can read 6 by 6 and still he is not happy. This is simply, we don't understand that concept of our patient in the mind. This is what happens if you miss the cylindrical power in low astigmatism. For a vision chart, all the patients with the vertical or a horizontal focus, if you ask him to read this alphabet on a white chart with black contrast, 100%, he'll be able to read. He'll be able to give you the first, last line very clear, 6 by 6 also. But look at the quality of vision. We never want to assess that. The quality of that vision is compromised. He's seeing everything. Some of them may point it out also. I see shadow behind that. So this is what happens to him in his life. What comes next if you miss on these small cylinders? And that is where our study said, headaches. These patients had frequent headaches. Now, all these toric lens users think that their spectacles can see better, but it's like this. The contact is supposed to be giving a lesser vision, is their thought. If you we probed these patients and found out that it was common for them to have headaches. This was also interesting observation. Whenever they wore spherical lens, there was a tendency to frown. And you'll find this in your patients. When you are examining your old contact lens patient, observe it. When they're reading the chart, is this a tendency for this patient to squeeze and read or try to frown a little bit? This frown will give you an idea something is uncorrected. And that is probably the uncorrected cylinder, which you have not done. And vertical cylinder, the eye lenticular can compensate, reading wise can be okay. But imagine a person with a frown always on the face. It's so stressful for him to be having that kind of frown. In fact, it develops those lines to look into it. But our life is now, especially after COVID also, it's going to be all computer screens, digital screens. Patients who have small cylindrical errors and have been given a spherical equivalent, if they are extensively computer screen users, they'll complain to you by late evening, early evening headaches and tiredness. I attempted this myself. I'm a presbyope though, but very small cylindrical error. And if I try to use my multifocal or my other lens, and I try to compensate this small cylindrical plus cylinder that I have, I really feel very uncomfortable in my office. And now, of course, sitting here, I do not have my lenses with me. I'm with my presbyopic lens correction, and I'm happy to see it. But if I would have to be using my lenses extensively on computer screen, it causes tiredness. So another important thing to learn, ask your patient all these things. Spherical equivalent, do you get frequent headaches? Do you get more often tired? And they may judge it or not. They may assume this is part of my things. But when we did our study and shifted them to the toric, they realized my headaches are less now. My tiredness in the computer is less. I can see far better. Not only that, look at this patient with a small uncorrected cylindrical. This is simulated and we imagine, and this is my own perception. When I wear it and I'm driving, I can see everything, I can drive, I can read the hoardings, but there are those shadows in driving which annoy me if that cylindrical is not covered. In driving, there are other issues. Somebody who has got a very active lifestyle and has a lot of driving to do. When you drive and do the reverse gear, your head moves. Look at the position of this picture and the eye here. you can see how much of eye goes into the extreme gaze. And imagine wearing a prism ballast design, it will rotate because the eye anatomy is now in a different direction. So you need to consider a stable design on the eye. Suppose you have given a lens which was a little bit fluctuating, wrong base curve, or you have given a prism ballast design in a very high cylindrical patient. You're likely to say, I don't enjoy my lenses on my driving. The vision would come and go, and that's the kind of fuzziness patient has. Imagine in a trial frame as you are moving the high cylinder. So what are the challenging situations if there is a toric lens patient who's having rotation of this lens on the eye? Certain situations like gym, sports, your eye movement, saccades, pursuits are so fast, your lens has to be so stable that it does move. You can't be having a lens which is, suppose it's a 2.25 cylindrical. A 5-degree rotation also will blur the image. Somebody who's sleeping at night, watching television, lying down on a couch with a head like this, the lens was made to be stable in a situation like this. The prism ballast design will rotate out. And that excess rotation means can be even 15-20 degrees. Look at the kind of headache this patient is going to get. So challenging situations where movements of the eyes are very, very rapid, you need a very stable design for your patient. We unfortunately overlook these things when we are deciding the lens for our patient. We do not look into the fact his lifestyle. We have to consider these things. Small cylinder, do not save his money. In fact, I cannot name due to professional ethics. We had a patient who was a famous cricketer and he had a 0.5 cylindrical. Now that 0.5 cylindrical, we do not get it in toric lenses. We gave him a 0.75 rather, but he had to use that contact lens while he was playing sports. So my question goes back again to the fact, so if suppose you have an axis calculation of 105 degrees and you need a contact lens of 105, manufacturer tells you, ma'am, I have 100 or 110. Which one should I give it to you? You just can't say, kuch bhi de do. Let me have any one. No. There is a science in it. The lower lid always has a horizontal movement towards the nasal side. So if the axis is, suppose you ordered 110, it is right eye, it will shift to 105. Suppose it was left eye, order 100 and it will shift to 105. So that is how you calculate, think scientifically. If it is right eye or left eye, you have to think it will rotate a little bit nasally. And if I move it nasally, I'm doing right. So you have to right, subtract from the axis and order simultaneously. So the common practice that India is barely 15 to 20% of toric contact lens sale in India clearly shows our practitioners are doing something wrong. And that is why not only teaching you the astigmatic fitting, which I know most of you would know it was clearly to bring in a thought. We need to change our perspective today itself. Our perspective has to be anybody 0.75 cylinder, whatever spherical power or more, think about only a toric contact lens for this patient. Symptoms like poor visual acuity, headache, strain, asthenopia, all this will come in. When all this comes in, I am sure people will drop out from the toric. And there is already a study which has been done, not in India, but outside, which says that patients complain, I'm not comfortable. The discomfort word can also be visual discomfort. And the significant number of patients in the dropout were those who were low astigmatics, like 0.75, 1 diopter, 1.25, who were not given a toric contact lens but were given a spherical contact lens. Now you may come up with a question to say, suppose this is a one-day disposable contact lens for occasional and party wear. I can take an attempt in this case, but imagine those symptoms of shadowy vision. If the patient is ready to accept, she's just going for a party and needs a one-day disposable, I may compensate. But again, I tried it. There is a difference between that corrected cylindrical and non-corrected cylindrical. So try to bring in, and now the difference in money for a patient for a toric lens and a non-toric lens is not significant. But the problems which he will get because of not being provided the astigmatic correction are much more. And the worst is you lose a patient from your contact lens category forever. He'll either go back to LASIK or to his spectacle. He'll think, I'm not a person, contacts don't suit me at all. Last key message, you all have to think about the material also when you prescribe your patients with toric contact lenses. You have to think about silicone hydrogels in the first case. So this is the diagram which shows you if you do not have lens on the eye, the blue color indicates, as you see in the graph, oxygen level which is reaching the cornea. So if I do not put in a lens, it's 100% oxygen from the atmosphere to my cornea, which is the food of my cornea. If I put in silicone hydrogel lenses like Pure Vision Toric, Air Optics for astigmatism, or Oasis for astigmatism, all these are the lenses which are meant for toric patients in silicone hydrogel. It's as good as wearing nothing at all. The cornea is healthy, physiology is beautiful. The difference is in the designs. This is Prism Ballast stabilization, and that's ASD design, and Air Optics is a combination. Now, SL66 is a hydrogel design. Look at the reds. The red zone means the oxygen. Because it is a Prism Ballast design, the base is much thicker. So this is the actual oxygen reaching the cornea flux measurement. The red is danger. The toric lens patient is going to have real dangerous values of oxygen if it comes into a Prism Ballast design and is a hydrogel. We really do not think about it at that time. But over the years, what happens? Neovascularization, limbal hyperemia, all the hypoxia complications come in. So if it's -3, you see the red zone is less, but if the power was higher, the red zone is much higher. So the key message, think about silicone hydrogel torics in the first go. Unless if you have to prescribe a hydrogel toric, it has to be a low power and also limit the number of hours the patient has to wear. It should not be extended hours so that the cornea remains healthy. Last, we should remember the care regimen. For any success story, teaching, training, care of contact lens is very, very important. Toric lenses have a potential of cracking at the laser mark. So please make them sure they rotate and then pinch it out. And conventional lenses I removed from my presentation because I do not believe in conventional lenses. I will believe in disposable lenses. So those are few clinical tips. And now I open up the forum for questions. And I request our moderators and Samuel, if you can just bring in these questions, whatever the patients want, people want to know.
Two questions which have popped up. And first question is like, how does hyperopic astigmatism patient respond with toric contact?
We have a lot of patients with hyperopia. There are limited brands and manufacturers who give especially a mixed combination or a plus with a cylindrical combination. Remember, you have to have a plus spherical and a minus cylindrical transposed form, and the response is very good. However, the myopes are better acceptors than hyperopes. But high hyperope, I even have examples of +5 with -2 cylinders successfully using. They are really addicted to these lenses because their spectacles are really thick and they are cosmetically not happy also.
So the next one is like, is there any change with the rotational stability in the with the rule and against the elastic matter? Or is it both similar? Is there a change in the rotation stability among the different plastic matter?
So you see, Prism Ballast design is the most popular manufacturer's design. But when we dispense, we just make them sit on the slit lamp. And we never bother them to look like this. You never ask your patient to read your vision chart like this, or just go around, drive, and do this kind of things. You know, on the vision chart, when the patient comes to you, you make them sit straight, he's a happy patient. But when he's in his real life situation, if there are small rotations which are happening, and if his lifestyle is very active, where his eye movements are very rapid changing, the design which is, and you have one base curve. You have to compromise sometimes, and you have 5-degree rotation, you just let it go, you know. So if that is the situation, then you shift the patient's design, and I prefer an ASD design, which is more stable in these corneas, where even when there is a rapid movement, that this does not fall off by gravity. So the ASD design, whatever is the head position, remains where it is. So we should actually make our patient try to rotate his head and read the visual acuity chart and tell you, I'm okay and I'm stable. Do that when you are dispensing.
And one more question is like, what is the role of lid tonicity on soft toric?
I didn't get you.
Lid tonus on soft toric.
Lid tonus, okay. So there are lids which are tight like this, which is the oriental ones. So you see the lid is tight and like this. It's not only lid, it is the eye position. Somebody's eyes are anatomically like this, some fall like this, some fall straight. So imagine the lens has to be in this. If the eye is anatomically like this with a tight lid, rotation will happen in this direction. So it's that is where you cannot predict. You put the lens on the eye and then only you will realize it is all this. This is the shape, this is the shape. We have various shapes. Some have a lower lid hanging out, some have an upper lid which is there. So it is how the lens lid reacts with that the rotation will happen or not.
And there is one more question. Will you like to convert a long time spherical equivalent soft contact lens user to a toric soft contact lens user?
Thank you for that question. I have done it. And I have had patients who have been now so dedicated to me. Even if I'm in my university, wherever the hospital they are, they think that I did magic to them. I did it. I gave them a trial. And when the trial, in fact, the study which we did in our campus with that student, till the patient had not seen the toric, he was okay, satisfied. The moment we shifted them to the toric, the difference is visible only after that. And these patients are now, I literally have those dialogues. Now I don't get headaches. Now I don't squeeze my eye. I'm happy on my computers also. This change you will find. So any long time user, demonstrate this difference to him. Just tell him there is something better, you know. And then what you do, even if you do not want to order and demonstrate, put the residual cylinder in the trial frame. Let him remove, bring it back, remove, bring it back, and he'll appreciate the difference. So that trial frame residual cylinder should be done. So in a toric patient or a spherical lens, any spherical lens, in fact, I missed on putting that slide. Suppose there is 0.75 cylindrical in one eye and there is spherical in both the eyes. Now the binocular vision is definitely going to be 6/5 because this had no cylindrical, and so the binocular, this is 6 parts, this is 6/5, binocular goes 6/5. But that 0.75 cylinder which was residual in this eye is going to cause me all those symptoms. It's going to disrupt my binocularity, my stereopsis, my binocular functions, my perception of focus of the image at the brain level. So even one eye cylinders, if we miss on prescribing that, it makes a big difference to the patient, not in terms of visual acuity, but in terms of headaches and asthenosia.
There is one question on about RGP torics now. Can you give an insight on RGP torics which are available in India?
They are not available in India, and since I do specialty practice only, and that's where our vision center in the campus we train, we do have all the types of patients. But there are times when I really desperately want a toric contact lens. We are in touch with Menicon, and I have done one toric patient years back. It was a high toric cornea only. So what you have to do is you have to do the patient with this was 4.5 diopter cylindrical and the same amount in the cornea. It was a corneal astigmatism. So you have to give the K values, you have to give the refraction to the manufacturer, you have to do a trial with the spherical lens and give a base curve fitting. They gave us a toric lens and we did fit that patient. However, it was very difficult. It took almost 3-4 weeks to get it and then another lens. So toric lenses are not available in India for one thing. The manufacturers will be happy to give it in India, provided practitioners start fitting it. So it's not one order in a year that goes to them. If many of us start thinking about it and learning about that fitting, it's not difficult. They will be happy to bring in those toric lenses to India also.
There's one more question on the difference between a front surface toric and a back surface toric. Most of the currently available lenses are back surface toric, so does really front surface toric make a difference?
So you see, back surface toric is going to align with the corneal astigmatism. So if you have a patient with, and what you need to see is only the spectacle power. Your cornea may be spherical, the internal astigmatism can neutralize it. So a back surface toric combines very well with the cornea and it is stabilizing there. When do you need a front surface toric? When there is a internal astigmatism also. So especially in case of irregular corneas, we do have specialty soft lenses for irregular corneas, which are even 8 diopters, 10 diopters of astigmatism, and we need to give in that kind of front toric designs in it. So you need to be sure in your manufacturers also. So if you see there is a residual astigmatism over it, you may have to change from back toric to front toric and things like that. Depends on the internal astigmatism also.
For the first time of toric Europe, will we suggest to fit a different brand of soft toric, like for a trial purpose, and then we decide on, or we have to stick on with the same?
So your ordering process is, you have to take the advance from the patient and empirically you have to order, and manufacturers also give you a credit note. Suppose your patient was not happy with your lens, you can refund and even they can give you a credit note to replace. So a first time user, and if it is a 0.75 cylinder, think only about toric. Talk to this patient that these are your available, this is the best recommended lens for you and it costs you this much.
What is the minimum amount of cylindrical power that a clear lens can compensate?
So if it's a 0.5 diopter cylindrical patient, as I told you, a famous cricket player who needed it for his sport, we could not get a 0.5 diopter cylindrical lens in the market. We gave him a 0.75. And 0.5 diopter, as research and papers say, gets easily compensated by a spherical equivalent. But 0.75 equal to 0.75 or higher than 0.75, toric should be given. So the toric lenses are available from 0.75 power only. And as I said, my personal experience, especially when we were giving, so this was one day disposable, this famous person wore, and he was happy with that 0.75. Very, very happy. And he says, my game improves a lot if I use that cylinder.
And based on your experience, what do you think is the best stabilization technique which is available at this point in time?
Okay, Prism Ballast in most of the cases works okay, like the Pure Vision 2, PV2 contact lenses. However, as I said, when you give a Prism Ballast design, you make your patient check on with the head rotation. So if you feel it is somewhere causing that movement, ASD design, which is the AQU design, especially in high cylindricals and with very active, challenging lifestyle, I would first go only prefer to give a ASD design to this patient because it's a much more stable design on the eye than a Prism Ballast.
There's one question, they want to have clarity on if there is an axis of 105. So what would be the recommended axis?
Okay, so as I said, if it is right eye and it is 105-degree axis, so the rotation is going to be right or left at that 5-degree. Now, in case of right eye, you are going into this direction. So you are going towards the left, right? So in right eye, there is always a nasal shift. The right eye is moving towards inner side, which is your left-hand side. So 105 becomes 110. Left add. Left eye, it is going to the right-hand side. So it has to be 105 minus 5, 100 degree. So this is 110 and this is 100 degree.
And there's one contact lens, Biofinity XR, where it says like the cylinder available is around till -5. So
yeah,
how this is going to help in correcting the carbon?
It is beautiful, and I really like Cooper Vision has a wide variety of even spherical. They give up to -20 sphere and they give a wide range. They have recently come up with the extended range of silicon hydrogel toric powers, and they work beautifully.
There's one question where with the fixation, the soft contact lens, the toric wearer who's wearing it and changes fixation from a distance target to a near target or a lying position, will the rotation stability vary? So
you mean to say when he is lying down and watching? Yes.
Yeah, lying.
Now, suppose it is a 0.75 cylindrical. That rotation of 5-10 degrees is not going to impact much of his vision. Suppose he's 3.25 cylindrical and he's lying down. By gravity, the lens has to fall in a Prism Ballast design. And that 10-15 degree, he'll start squeezing, or what he will do. Another thing, it's a good observation. When your patient, make him sit on in the vision chart in the clinic, and he's wearing a toric lens, and you ask him to read. If you see your patient doing this, he's trying to adjust his axis. And then he's trying to read. This will also give you a hint, the stability is not good. So if you find somebody who's again and again doing like this, you can even question your patient, or you can question the family member of your patient. Do you do this, or does he touch his eyes very frequently? If yes, that means it's a behavioral thing which has come in by doing that kind of thing.
We are almost done with questions. We'll just take one. If there is any change in the rotation when the patient fixes from distance to near.
And not sure of it. I don't know. Any I'll share this presentation, and I think you've recorded it also. Anytime if somebody needs, I can share the notes also.
Yes, ma'am. This is actually recorded and it will be there in the YouTube channel. It will help you for the viewers also. Any more questions from any of the panelists online?
Sam, I think ma'am wanted to leave a little early because she has a session at 6 o'clock.
6 o'clock session again, where we have Dr. Bhatti demonstrating us the use of the phone and then clicking the imaging and other things. In fact, today we had certain other knowledge and we were probing into it. There are almost 30, 40 apps, and these are beautiful apps by which you can do contrast, you can do visual acuity, you can field, you can do imaging, you can even do gonioscopy. In fact, one of the app which is developed by an Indian ophthalmologist is going to come up in the market is using this app and your smartphone to do gonioscopy. And the discussion that was happening was, it's the optometrist which need to be trained on it because these are beautiful. And I think we are in a generation, when we go back, if all these senior people my age would realize what we were when we were child and what we are learning today, the whole books that I read through in my optometry are obsolete. I do not even teach that. I do not even practice what I read. I read hard contact lenses in my graduation. I never even see them now. And whatever the technology is moving so fast that it's really tough for us to learn everything right now at our age. So we expect our younger ones to learn better, and then I think we can just assign them the task. I think it's really challenging time for any one of us at our generation to keep pace with the way we are hearing things entering into it. I think too much of change is happening, and COVID has brought in that change. They were existing, but a lot of research is now going into everything becoming smartphone based, technology based, remote based. And the beauty about it is we all learned a lot. Sitting here in Gurugram, I wouldn't have been attached to my friends. We know you on the WhatsApp messages and chats, but it is so nice to see you live here, everybody. And it's so nice that we can now, the best thing that will happen in optometry is